Good evening, Kushag, Chandra, Pratham, Tanmay. Very good evening, everyone. So, in this lecture, we are going to work on a new project that's on style transfer. This will use again deep learning neural networks. Deep learning or neural network, both of them means the same. But here we are going to discuss about a special kind of neural network that's called as generative adversarial networks. Okay, so first of all, we need to discuss where exactly this map lies. We'll discuss about the history of computer vision first of all, and before that, first of all, we need to discuss what is style transfer. Anyone wants to give it a guess? Do let me know in the chats. What is style transfer? What do you think the project is gonna be? What is style transfer?
Take a photo and basically apply that to another photo. The
Yes, that does
styles.
make sense. That does make sense. So making a Ghibli art, yes, trying to mimic a style similar to transfer learning yesterday, maybe. Just a guess. Yeah, it's a guess, Apurva. Not correct, but yes. Augmentation. Yeah, bad guess. Okay. Uh, but basically, transferring one style to some other. Okay. One perfect example can be in probably 2 or 3 years back, at least 2 or 3 years back, there was an app named as Face App. Have you guys tried that? The name of the app is Face App. Yes, Nilesh has tried it. Okay, from iPhone, yes, yes, it was at iPhone, probably at Android as well. So, what is famous about that app? In Face app, you can click a picture of yours. It will generate a male version of you. It will generate a female version of it. It will generate how you will look if you are bald, if you have beard, if you uh, probably are from some other continent or looking older. This is what they does, right? This is yes, Snapchat works the same. Yes, in Snapchat is we have different kind of filters, but those are visible filters that can easily distinguish. Okay, this is a filter that they have added, but in Face app they have used a generative model that can generate realistic image. Okay, now in this particular project that we are going to work on, we'll take an image of a male. We'll see how the person will look if he's a female. Okay, if he is a she basically, and vice versa as well. We'll see how that part can be done. That part can be done, and for that purpose, we are going to train the algorithm from scratch. Okay, that is the agenda of this lecture. So at the end of this lecture, you will be having an image generator that will generate the image, and not only generate the image, but you can also do the style transfer to this. Uh, and in this particular case, we are going to build it from first principle. Now, first principle means if you need to build the algorithm from scratch by yourself, so how will you build it in the first go? We are not going to use any pre-trained model that already have the knowledge. To build that pre-trained model as well, we are going to make the model by ourselves. So it's based on GAN. Yes, it is. It will be based on GAN. Okay, but before reaching to GAN, let me introduce to the whole workflow of this. Okay, so whenever I'm talking about neural networks, so after neural network, we have two paths. Okay, before you guys say it. Okay, so now the thing is, uh, whenever I'm talking about neural network will take two paths. Okay, first path is the NLP one, where we'll have language models, we have language kind of architecture, or for sequential data, RNN, LSTM, GRU, bidirectional transformers, LLMs, all these things are the things that you can see at the bottom. Okay, and on top we have the data where we work on images. Okay, for vision basically. Okay, so earlier we have tried it as well in the last project, means last project. We have made a project that is working on images. Okay, but we are making an ANN, artificial neural network. We were not using CNN layers, but still the model was working. Right, we have done it for Fashion Amnest. That was not giving the best accuracy, but that was working. But after that, like probably 15 almost like 10 to 15 years ago, there is a new architecture evolved that's called as convolutional neural network. That is something we have discussed in the last class. In convolutional neural networks, this is a special kind of a network that can do feature extraction from images. It will not convert the whole image into one dimension. It will take the image as it is. It will do the feature extraction part after doing the uh, taking the image, resizing it further and generating different variations of it. That's what we do in ConvNet. But this is one of the major leap where now I can train a neural network specific to images. Okay. And this worked great. And after a couple of years, there is a technique of transfer learning that evolved, through which I don't need to train a model from scratch. I can use a pre-trained model, and from that pre-trained model, I can use transfer learning so that my model can do the best in less number of epochs, in less training, with even less sample. This is the reason because of that AI evolved, AI flourished, because now companies don't need to train the model from scratch. With very less competition, they can also get state of the art result. Okay, so this is also one of the benefit of main benefit of getting famous of the deep learning or neural networks, because we also have transfer learning here. And in the last class, we have done a detailed discussion on transfer learning. Now, after that, if you're talking about both of them, convolutional neural networks or transfer learning, both of them work for classification, right? Usually it will classify. It can also do regression, but mainly we are using it for classification. Like if the images of a cat or a dog, or like if the X-ray shared with you has pneumonia in it, or the mammograph that shared with you has like benign or malignant cancer or non-cancerous. So these are the classification kind of tasks that we usually do. Okay, but then a new kind of problem statement emerges that's called as, we call it as object detection, right? Right now I'm talking about different kind of algorithms, not algorithm, but problem statement that evolved. So then we have object detection. Before that, we have algorithm that can say in the inside this image we have a dog, a cat, an image, but the algorithm cannot detect exactly at which particular place we have a person, at which particular place we have a dog, right? We are going to have a dedicated lecture on object detection algorithm as well. Don't worry about that. But this is a new kind of algorithm that evolved. Right now, we know how to do classification, but how will I get to know at this particular place we have a person, at this particular place we have a car, at this particular place we have another person? Okay, so this is a new kind of algorithm that evolved, and YOLO is one of the main algorithm, one of the most popular algorithm for object detection. Okay, we are going to have a dedicated lecture on this, so I'm not going deeper into this. And then we also have problem statements like object segmentation. Right now, what is object segmentation? It will not only tell you at this particular area we have a bull or a person or a chair or a table or scooty or bus probably. It will also go pixel by pixel at exactly at this particular region we have a cow. Exactly at this particular region we have a person. Okay. So to do that, we also have model called as UNit. We are also going to have a dedicated lecture to this. Okay. UNit and detection, these are the models that we'll see. Okay. And this UNit model is kind of the first model, like UNit and GAN, both of them, that can generate images. Okay. UNit, let's skip it for now. This is the model that I'm going to talk about today. This is generative adversarial networks. I need to change the color to this one so that I can see what exactly is there. So bear with me even if the brightness is too much. So this is generative adversarial network. This is one of the first of its kind model that can generate new content. And if you look closely, this comes under deep learning. This is not a generative AI algorithm. Though it can generate new text, new images, it's not a generative AI algorithm. Right? Now, the question might arise, okay, if it can generate something new, why we have it? If it can generate something new, why don't we have it in Gen AI? Because the funda is, GAN algorithms, like GAN is a model that will generate great images, but they were very specific. Like there was a model that can generate very realistic images of a face, and the algorithm that is generating the image of a face can only generate the image of a face. It cannot generate the image of a cat. That is a big problem in those networks. So what companies has done, company has trained these models on all the available images on the internet. I mean, not all the, but a very large portion of the images, where we have like couple of 100,000 classes. And if the companies are training these models on this giant data set, so, and that too on GAN based or diffusion based models. So now the images will be generated. One model can generate, I mean, any image of your choice, because the scale is massive. We have a lot of data, all the data around the internet. Because of that, this is a new field that emerged that called as generative AI, Gen AI. Okay. But in AI as well, we have a couple of algorithms that can generate something new. GAN is one of them. Now, today's lecture will evolve around GAN. Okay, first of all, we'll do a rough intuition about GAN, how GAN works. Then I'll tell you about the project, today's project, how we are going to make it. Because if you understand the concept of how GAN works and what is the overall project flow, you will understand everything pretty clearly. Okay, so we have GAN that can generate images. We also have UNet model that can generate images. And you might have heard about this diffusion model. How many of you guys have heard about this? Diffusion models. Yes, you might have heard about this term. Probably you might not know it, what exactly it is doing. But diffusion models are one of the most uh, realistic image generators so far. Not exactly till now, because now we have a better version of it that's called as transformer based architecture. But in diffusion model, those who have used diffusion based model as well, here I'll take a very noisy image. I will step by step reduce the noise from the image and generate the image of whatever that I wanted. This is how diffusion model works. Okay, and here you can see we'll take an image, generate a better version of it, then give this image to another model, means the same model, it will generate even clearer image. Then give this model the same image, even clearer image. So this time the model will generate a realistic image in step-by-step manner. But if I'm talking about GANs or UNet model, they will generate the images in one shot. So because of that, diffusion model can generate very realistic images because it is doing a very smooth image generation. Okay, until last 2 or 3 years as well, diffusion models are state of the art. In last probably till last year as well. But then companies started building a transformer based approach to generate images as well. So because of that, all the previous things, for example, if I'm talking about all the models, be it ConNet, transfer learning, detection, image, GAN or diffusion, all of them are somehow using convolutional neural networks. Like exactly the thing, the thing that you have just started learning, that is the thing that we are using from last 10 years. But then there's a new technique evolved that has changed the way we are using vision. And that is using transformers. We call it vision transformer. That's the slide I need to add after that. But this is the whole map that we have in computer vision. These are the main things: object detection, segmentation. And now let's go to GANs. Let's have a basic discussion of what is GAN and how GAN works, how generative adversarial network works. Okay. Now the thing is, imagine, so like these are the main four image generator model that we usually take. We have GAN, UNet, diffusion. These are the three things that I have told you a brief about it. And we have autoregressor technique that is using transformer to generate images. You might have used Nano Banana, right? If not Nano Banana, you might have used any image generator right now that is there, like Stable Vision. That's correct, Vivek. That's one of the models that we have that use diffusion models. Gemini, Nano, Banana, that's there are a lot of things that you might have used. All of them are using autoregressor models. Okay, or vision kind of a thing, like vision transformer kind of an architecture. Now there are other things that will discuss after that, but the first thing is GAN, generative adversarial networks. Let's discuss about that. Imagine we have a person named as Alex, another one whose name is James. Can anyone make it a guess what they are going to do as per the appearance? Do let me know in the chats. Okay, so one of them is a detective, and another one might look like a thief, right? And that seems correct, but they are not the traditional thieves. Okay, psycho killer. Okay, uh, they are not traditional thieves. So if you look closely, they don't steal paintings; they make realistic paintings. Okay, so at the left we have Alex, who is great at art, generating images or painting, and James is a critique who knows the nuances between a great painting, a real painting, and a fake painting. Okay, so if both of them working together to generate hundreds of thousands of paintings, so this critique, James, can basically go for a feedback loop to Alex that these are the problem with this painting, this is the problem with this painting, you need to do it in this way, you need to do it in this way. So they can make very realistic fakes. This is what they does. They work together, they'll not steal painting, they'll make very realistic fakes. Okay, so if they are making very realistic fakes, so at the left we have generator who is generating new paintings, and at the right we have discriminator who is great at knowing this is a real painting, this is a fake. Okay, now they can make any painting of your choice if they are working great, if they are working together, right? That does make sense. They can make any painting that they want. But the thing is, if in the beginning, do you think when they are making the first painting, they were making great paintings? They are great at making paintings? No, obviously not. The painter don't know how to paint correctly, and so does the critique also don't know. Like this is exactly the how the real painting looks, and this is how the fake looks. Okay, they learn through time. Exactly, so they learn eventually with time working together. Now the thing is, in the beginning, they will make paintings something like this. They'll not make great paintings. They'll just like, okay, this is and this is how it works basically. Now the thing is, if this is how their collection also looks, but over time they evolved. And now, because of time, because of going for thousands or thousands of painting, now they can make very realistic fakes of any painting of your choice. Now, tell me, now, because after making hundreds of thousands of paintings working together, now Alex thought, now because I know all the nuisances that are there between a real and a fake, Alex now knows what I need to make. After training, after working on hundreds of thousands of paintings, Alex know how to paint any painting of your choice. Now, do you think he need James? No, right? Ideally, you can say like mostly no, because if they want to make something totally new, then that's a different thing. But for most of the thing, the person Alex single-handedly can make any painting of your choice as well. So here, discriminator is not needed. Only generator can do the things. Okay, and this is what GAN is. The story basically represent the whole thing. What is generative adversarial network? Okay, now let's see the exact architecture of it. Okay, now if I look about the presentation, thank you, thank you, thank you, thank you. Okay, now if I go to the training data set, in the beginning, we have real world images. Does this make sense? And we have a generator. The work of a generator is to generate paintings, right? So here generator is a neural network. I'll go to the detail of the generator as well. But right now, just think of it as a generator. The generator, because it's a neural network, it will take something as an input. And that is a random noise. Think of it as a giant array of 10 numbers or 100 numbers. They are totally random. This is the exact thing you will see on a dish TV cable when there is no network. You might have seen in your TV as well. Okay, so we have noise given to the generator, and generator will generate an image. Now you might be thinking how generator will know like I need to generate this is how a person looks. So in the beginning, generator cannot generate an image. In the beginning, generator will also generate very random images. But along with that, we also have real face images data set. Okay, so generator will learn from these images, but directly the generator cannot learn. So what will happen? They will use a discriminator. So generator will make a painting. At the left, think of it as a real painting. This is a fake. Discriminator will say, okay, this is not the real painting. This is not the real painting. This is a real image. This is not a real image. So discriminator will take both the images and do a basic check like this is a real image. This is a fake. If you look at the discriminator, the task of the discriminator to just give one of the two outputs. It is real or fake. So a discriminator is just a classifier, right? The discriminator is just an image classifier, doesn't it? And because discriminator is just an image classifier, which has just two outputs, one or zero, real or fake. So in the discriminator, I can use a convolutional neural network that will take an image as an input and it will classify real or fake. So discriminator is pretty simple. It is just an image classifier that will say, this is a real, this is a fake. And in the beginning, it would be very easy for discriminator to say, this is a real, this is a fake. Because in the beginning, generator will generate something very random. But over time, I have now two neural networks, generator and discriminator. If I talk about generator, it will eventually, when I'll train both of them, generator and discriminator, the generator will start making realistic images step by step. Not in the first go, it will take a lot of iteration, but eventually it will reach there. Now the thing is, here I have two neural networks to train, and rather than giving the data set of faces, can I give the data set of cat? What will happen in this particular case? Can the model generate new images of cats? It provide feedback, yes. Okay, if I'm giving the data set of cats and then training this both the networks together, generator and discriminator, can it generate cat images? Then it can. If the data set is of cat, it will generate images of cat. If the data set is of dogs, it will generate dogs. If the data set is of cat, it cannot generate a dog. Obviously, that does make sense, right? But the thing is, here the image is generated from this random noise. Okay, this is a random noise that is given to the generator. It will generate an image. If exactly same noise I'm giving to the generator again, it will generate exactly same image. Okay, so think this noise is somehow mapped with an image. Okay, and in the exact same way, I can have a Persian cat. So for Persian cat, I can also have a noise that will generate the image of a Persian cat, right? And eventually, if this is how it works, these noises are responsible to generate the image, be it image of Indie cat or a Persian cat. These noises are responsible. Okay, and it's same like if I'm generating this images, I don't need a discriminator. If my model is trained, I don't need a discriminator. Now just generator is enough to generate images. Okay, now if I just talk about this one, now just noise is enough, it will generate the images. Okay, now I just have a question, and the question is, imagine uh, if my data set has more images of Indie cat, less images of Persian cat, then if I have more images of Indian cat in the data set and less images of Persian cat, so generator will generate more images of Indie cat or Persian cat.
You will overtrain the data.
The model will become biased, right? It's same like if I'm giving if I want to make a face generator inside the data set, I have more images of females than males, so model will become biased. Model will more frequently generate female images. Okay, so this is data biasness. This is one of the main reason why if you are asking ChatGPT to generate a realistic image of a business person sitting in the office, the model will most probably generate the image of a male. Why so? Because it's data biasness. If my data is biased, it will be showcased to the model as well. Okay. That's our, okay. The model will take the biasness from the model as well. Okay. So it's like teaching kids, it's correct. And what is correct, what is wrong. Yes. Okay. Also Western ACS, we can go for that as well. Now the thing is, if my data is balanced, model will learn that balance, that biasness as well. Now I'm going one step deeper. I hope it is clear so far. If I will take all the noises that can generate an indie cat and all the noises that can generate a Persian cat, how, I don't know by now. Okay, but you will understand at the end. If I can somehow take all the indie cats, find their average noise, take all the Persian cat images, finding the average noise. So can I say this noise has perfect features of an indie cat, right? And this average noise has all the feature of a Persian cat. Now, if I say this is the average, this is the feature of an indie cat, this is the feature of a Persian cat. And in the exact same way, I can have, if I have a very big data set, I can also find the noise of all the different noises, right? And eventually what I need to do, just take any two noises, add them together, and one noise is think of it as a giant array of numbers. It looks like a QR code, but it's not a QR code. It's just random noise. Okay. So if I'm adding both the noises together, it's just like a 10 by 10 size matrix. In actual, it is a 1 by 100 size matrix. So if I'm taking 1 by 100 size matrix plus 1 by 100 size matrix, eventually you will get a new vector, right? Which has the average feature of an Indie and Persian, not 2 out of 100. Eventually they are vector addition. 100 size vector plus 100 size vector will not make a 200 size vector. It will make still a 100 size vector. Okay. If I'm adding both of the things, give it to the generator. What do you think the model will generate? What do you think the model will generate? The model will generate a new cat which has the feature of Indian Persian, right? We have it. In the exact same way, I can change these features. Rather than taking Indian Persian mix, I can make, like, here you can make it a guess which are the I would say features that the model has. So this model has a feature of a husky and a tiger and a leopard, and also like it looks like peacock. So these are the features that this model has. Along with that, you can also make another combination. Now it looks funny. This is just to show you, like, this is how it works. Okay. Now the generator will take the noise, and here you can see now I'm somehow guiding this noise through my own classes. Like, but for that purpose, I need to have the noises first. Okay. So what I can do, I can go for a step by step things as well. Rather than having indie cat, I can also have just noise of just indie and just cat, so that the model will understand we also have indie dog. So there will be a dedicated noise to indie and cat. We can also have the noise to every word of your choice, right? And we cannot have two separate noise for the same word. So it should be common thing. So if you look closely, I can have one noise for every word. Okay, think of it as embeddings. Now, embedding is something we'll discuss in NLP lecture, but think of it as it's a visual represent. It's a numeric representation of every word. I can have a numeric representation for every word. If that numeric representation can guide my noise. So now I have all of them, right? Now what I need to do, eventually think of it as this particular sentence: black Indian cat sitting on grass early morning in Antarctica. Eventually every word will have a noise, right? I can do the average. Rather than doing a direct average, I should go for weighted average. There are some words that are more important than other. So I'll go for a weighted average. For that purpose as well, we have a couple of algorithms. Don't go there. This is a superficial discussion I want to have. After that, I'll do the weighted average. I'll have this new embedding or representation of the whole sentence. Can I give this to a generator? It's like vector embedding. Yes. Can I give this to a generator? I can give this to a generator and it will generate a new image. Okay, and eventually you can also go for something very complex and it will generate that image as well. Okay, so this is the basic principle of how generative adversarial network works. Here we have two networks, a generator, a discriminator. Both of them are trained side by side together. And once my generator knows how to generate very realistic images, I don't need discriminator anymore. Thus, generator is more than enough to generate the images. And that's it. This is what GAN is, generative adversarial network. Now, what I'm going to do, just to make the things a bit simple for you, I think I have made it enough simple. Uh, Obviously I can make it even more simpler, but I think this is enough. Now the thing is, this is how GAN works. Now what I'm going to do, now let's go for today's project, what eventually I'm planning to make. Okay, anyone has any doubt on this? I don't think so. How does the relationship between the words? Okay, so word is just to show you how we have couple of models. If I can somehow guide this noise through words, that's the best thing we can do. If I can somehow guide that noise that is given to the model, that's the best thing we can do, right? Now what I'm going to do, I'm going back and let's see the project that we are going to make. Now what we are going to do, first of all, we are going to make a generative adversarial network that can generate the image of face. And for that purpose, I'm using celeb face dataset. This is the celeb face dataset of celebrity faces. This has like how many images? A lot of them. This has 2,02,599 images of different celebrities. Okay, and you can go also go to this one, and here you can get some of the sample images as well. Like this is fun. There's another one, another one, another one. So they are close-up face images. Okay, and you can also get some of the familiar faces as well because this model has them. Okay, so if I scroll a couple of them, you can get some familiar faces. Okay, not right now, but you will get it. So now the thing is, I have this model, I have this data set. On this data set, I am going to train a generative adversarial network. Now, eventually, what you will get, if I'm giving real world images to generate, to make a generative adversarial network, what will happen? Can I say my model, first of all, I will have a generator, I'll define a discriminator that will learn from the data. And once it has learned from the data, the generator can make realistic face images. Does this make sense? Yes. This video will be available, uh, like, yes, those notes. Specifically, I have recorded a video for that as well, just explaining GAN. So it will be available on the YouTube probably by Friday. So I'll share you that link as well. We need to any cats only, how will then data and all. We need to give more data. The generator need to have all the data available on the internet. Okay. Now the thing is, this whole architecture will understand how to generate a realistic image. And what if my data is biased? What if I have more images of women than men? So my generator will generate more images of women. Right? And eventually what I'm going to do, I'm going to take just this generator after that. So first of all, I'll basically train a generative adversarial network so that I'll have a model that can understand how to generate realistic images. Okay. And after that, what I'll need, I will just need a generator. I don't need anything else. Then I will use a generator. That's it. Because now I have a generator that can generate realistic faces. Okay, so first of all, I'll make a GAN, train on this so that I'll have a generator that can generate realistic images. Now what I'll do, I will add a classifier. Okay, you might think, okay, what the hell I'm doing, but at the end, like just bear with me for 5 more minutes and you will understand everything, hopefully. Okay, so now what I'll do, First of all, I'll train a GAN, generative adversarial network, that can generate realistic images. Then through that, I will just take the generator that can generate realistic images. Once we have the model that is generating realistic images, I will give it to another model. And this is not a discriminator. This will not classify this is a real image or a fake. This will classify if this image is of a man or a woman. Okay, so this time I'll not have a discriminator that will discriminate, okay, this is a real image or a fake. This will discriminate if the given image is of a man or a woman. So these are the two classes that it need to have. Okay, so now if you look closely, these are the two classes the model will have. Okay, so this is the flow. First of all, I'll make a GAN that can generate realistic faces. After that, I will give random noise to the generator and ask it to generate new images. The generator will generate new images, right? Then whatever image this generator is generating, I will take this image, give it to another model that is not a discriminator that will say if it is a real or a fake. It will discriminate if this is an image of a man or a woman. So eventually, this noise, from this noise, I will get if this noise is generating the image of a man or a woman. Okay, so eventually my main goal is to have this noise and the map of the noise between, like, if the noise is generating the image of a male or a female. Eventually, this is what I'm doing, right? If this image that we are generating is of a male or a female. Okay, and you might already know this is just a classification based model that you can make. You can make it using CNN as well. Okay, so once I know this noise is generating the image of a man, then I will give another noise, and then you can see this another noise. For example, this is what, let's do this. So I will have a noise that will generate the image of a man. Okay, then I'll have another noise that will generate the image of a man again. Then I'll have another noise that will generate the image of a woman. Okay, if I'm doing it for hundreds of thousands of them, so can I say, and also saving all the noises, not only the output, also the noises, like this noise is generating the image of a man, this noise is generating image of a man, this noise is generating the image of a woman. And now if I can somehow find the average noise of a man vector, and in the exact same way, average noise of a woman vector, exactly, if I go back to Canva, for this, there is a slide that I've shown you, right? Where I was saying how we will find the noise. If I can somehow do this particular part, I'll find all the images of a male and a female, or basically a cat, Indie cat or a Persian cat. I will find their average noise that is responsible for generating this image. How we will understand this is an Indie cat? Because I already have a model that can classify this is Indie, this is a Persian. So eventually, if I have something like this, so I'll go for a sample of 1000 noises that will generate image of a man. I'll find 1000 noises that will generate the image of a woman. And I will find the average noise that will generate the image of a man, average noise that will generate the image of a woman. And eventually, this is what I want to find, right? If I have that vector, then rest of the thing would be easier. So what I need to do after that, I just need to have this random noise, and this particular map is already built. Now I just need to take this particular vector, give it to the model. It will hopefully generate the image of a woman, Indie cat, sorry, and this one will generate a Persian cat. In this particular case, if I have a random noise, now I know this is the average noise of a man. So I'll generate an average vector for this. So basically from this, I'll generate an average vector, like I'll average male noise. I'll get an average male noise and I'll also get an average female noise. Does this make sense? From this map, I can find the average male noise and average female noise. And that is up to you how many samples you want to take. If I want to go for 1000 samples or 100 samples, that's totally up to you. So I'll get an average male noise and average female noise. And from this, I hope it is clear so far, right? Where's the code? I'll get to the code as well. Code is not that difficult. Code is not that difficult. The process is a bit difficult. If you understood the process, rest of the thing would be pretty easy. Okay. Now the thing is, this is average male noise. This is average female noise. And now tell me one simple thing. Average male noise is a vector, right? Average female noise is a vector. What will happen in this case? What if I subtracted both the noises? Average male noise will generate the image of a male. Average female noise will generate the image of a female. Okay. What if I'm subtracting average male noise and average female noise? Can I say this is equals to a gender vector? Can I say it like this? Average male noise and average female noise will have a gender vector, right? And if I have a gender vector, I can take a random noise. If I have a random noise, if I'm adding gender vector into it, the image will become more manly. If I'm reducing gender vector to it, the image will become more womanly, female side. I don't know the exact word. Does this make sense? If so, here this is the average male noise, this is the average female noise. If I'm subtracting both of them, I will get basically a gender vector. This average male noise will have all the features needed to generate a male image. This one will have the features to generate a female image. But if I subtract both of them, the final vector you will get will have the whole knowledge that will make a male to female or female to male. Right? If I'm subtracting both the vector, so in between, I should get the features that will make a female to male. Because this one is generating male, this one is generating male, female. So both of them will have their own things in common. But if I subtract them, I'll only get the difference that will make a difference between a male or a female. Okay, is this subtraction result at absolute value? Okay, will not go for absolute value. We'll just subtract the things out. That's it. A matrix to matrix subtraction. That's it. Okay. And human characteristic, not human characteristic, because human characteristics are there in male and female as well, in both of them. It will basically have how, based on which noise, based on it will have the characteristics, what exactly make a male to female or female to male. Okay, sorted. So I hope the funda is clear. And now the thing would be pretty easy for you because, and let me just make it a recap what exactly what we have done. Don't think of it as like if the gender vector I need to subtract or add, that's something we'll see. Okay, because it's pretty easy. So I have a GAN that can generate realistic faces. This is my step one. Step two is I'll just take the generator to generate some images. Then step three is I will make another classifier that can classify between a male or a female. So I need to train another model that can classify a male or a female. Okay, if you don't want to make a model, you need to manually generate the images and manually you need to save it. Like this is image of a male, so save that noise. This is image of a female, save that noise. I want to automate that process. So that's why I have made another classifier that will generate the image of a male and a female. And eventually, by combining both of them together, I'm generating these noises. I'll have hundreds of noises that will generate image of a male, hundreds of them that will generate the image of a female, through which I'll get an average vector. And once I have that average vector, I will subtract both of them and I'll have a gender vector. So gender vector is something I'll manipulate. Okay. And this is not, I would say, the best technique that will generate it, but this is my personal project that I have tried and it worked. So on first principle approach, if this is working, so this project will also tell you how you can do surgery on that model. Okay. So now let's go to the coding part. And for the coding part, uh, let me go to GitHub. Okay, and let me guide you through the whole project. So because this has 3 to 4 separate models out there, so I'm going to take all of them side by side. So this is a face generator that will generate the images of a face. I'll go through that. Then I will make a gender classifier that can say this is image of a male, this is image of a female, and then this is style transfer one where I will do the style transfer. So let's start with the gender the face generator. What do we have in face generator? For that purpose, here you can directly go for this link. It will open the Kaggle notebook. You can go for this link. It will open the Colab. Okay. And not only that, you can also see there are trained weights as well. I've trained this model for 700 epochs, and this one is generating some decent images. It can generate decent images, and this is the IPYNB file that is can generate the faces. Now, either you can go for this one or you can go for this one. Both one will work. Okay, so let's go for this one. So in this particular case, face generation with GAN. So this is okay. So if you look closely, okay, what do we have in generative adversarial network? In generative adversarial network, we have a generator that will take a random noise as an input. Okay. If I zoom a little bit in. So you can see every image has 128 by 128 by 3 size. Okay. I have a noise dimension of 100 size. So that means every image will take 100 size random number as an input. Not random number, but random array as an input. I'll take 128 images at a time, generate it as a batch, and then train the model. And I'll train the model for 50 epochs. This is from where I'm loading the data because this is inside self phase. So if I go to the version 1, or you can also click on edit. I'll share this link with you guys as well. Don't worry. Okay. So if I click on edit, so here you can see it will load the existing data set. Not only existing data set, here you can see that existing data set is loaded where I have the same data set. And if I am executing it, it will load the data set. Okay. And so far I am adding the data loader. After that, here comes the generator. Here comes a function that will take a noise dimension as an input. So here you can see input shape is noise dimension, means basically it will take 100 size array as an input. And then it will make, here you can see I'm adding convolutional 2D transpose. Now what is convolutional 2D transpose? It is reverse of convolutional. Convolutional basically used to reduce the dimensions, right? But con 2D transpose will increase the dimension. So it is basically it's a reverse of what we have in classification. If I go to Skeledraw and this is how it works, right? If I'm using convolutional and eventually I'll have 1094 size vector, but inside the generator, I'm doing this process in reverse. I'll take a 100 size vector, I'll do reverse convolutional, transpose convolution, convolution transpose, and eventually I'll make an image. So this is the reverse process of that. So here you can see I'm adding some couple of more. Eventually I'll reach 128 by 128 by 3 size. So this is the generator. And along with that, I'm also adding a discriminator. Discriminator will do what? It will take the same image given by the generator as an input and classify the images either fake or real. So in the final layer, I'm adding a dense neuron with 1 value because the neuron can be 0 or 1. 0 means uh, fake, 1 means real. And eventually I'm adding binary cross entropy. And here is the code that will train both the models side by side. Okay, and eventually here is the code that will train the model. Okay, there are a lot of nuisances into this model, into this whole code, because I want to not dig deeper into everything. It will take hours. Okay, but here eventually I have trained, made a generator, a discriminator, and I'm training both of them. And inside the training process, if I go back, I have trained this model for a couple of hundred epochs. And once it is done for like 800 epochs, because I've executed this function 8 times. So 100 into 8, 800 epochs. So after that, I've saved the model, saved the weights. Once the weights are saved, what you can do in between as well, like if you are executing the code, the model will not just train the model, just train it. It will also show you the samples, like after one epoch, after 10 epoch, how the image looks. And here you can see these are some of the very basic images the model was generating, and that too after this is that look like this is epoch number 1, but this is not the first epoch. This is epoch number 701, because I've also already executed this notebook, this particular part, couple of times. Okay, so here's an issue, but okay, let's go ahead. The second thing is, now if you look closely into it, these images are not that realistic. Can you tell me why? Why these images are not that realistic? For how many days? I have trained it for like just 7 6 7 hours, just 6 7 hours. Like some of the images are uh pretty nice, right? For example, this one is uh like it looks like fake, but it still have all the features intact. Decent, yes. So the thing is, because if you look at the generative adversarial network, when I'm training this GAN, so how the generator is learning? The generator is learning because of discriminator. Until and unless the discriminator is saying this is looking like a face, this is not looking like a face. This is the main agenda of discriminator, right? So if the generator can fool the discriminator that this is looking like a face, so this is what the generator need to do, right? So even if the image is looking a bit like a face, the generator will see, okay, this is looking like a face. And because of that, even if the features are not very great of a male or a female, it will still say, okay, it's looking like a face, right? So this is the problem with discriminator. But giving more data, giving more training time, the images will become more and more better and better. Okay, how does it fool the discriminator? Because both of the models are training side by side. Generator will generate in the beginning random images. Discriminator will say, okay, this is not a real image, this is only a real image. Okay, so step by step, it will start generating realistic images. Okay, how does we increase the accuracy? First of all, this model will not have any accuracy, because it's not like how many images uh, are predicted correctly. This is not that kind of a scenario. Here we don't have accuracy, but how we can make the model better? I can give more training time. I can add more uh, layers into it, so that rather than generating 128 by 128 size image, let's generate 256 by 256, 512 by 512, and give more data to it. Okay, or eventually go for better version. There are different variations of GAN as well. We have cycle GAN, we have vanilla GAN that will generate even a lot better images than this one. Okay, so talking about this one can generate some realistic faces. And what you can do, you can also clone this particular repository, load this generator underscore 700.h5, give it to a random noise of 100 size, and it will generate an image for you as well. Okay, and this is exactly what is happening here. Okay, so if you look closely, what I have done, I'm cloning this repository, face generator GAN. This is just that I've shown you. Okay, after cloning the repository, there is a model named as generator underscore 700.h5, right? So I have loaded that model through TensorFlow. Once the model is loaded, I'm generating a random array of 100 numbers given to the model, and the model will generate a new image. It's not looking like a human face, means not looking like a realistic human face, but for a discriminator, it is enough to fake, to fool the discriminator. So eventually I need to give more data, more training time, then the model will become better. But now here, if you look closely, okay, this is generating the final images of different variations of it. And there's something I'll discuss at the end. But before that, there was a process of, now I have made the generator, right? I have a generator ready where I can give a random noise, it will generate the images. Now my task is to make a male versus female classifier. For that purpose, this is the model that I have trained. A gender classifier with MobileNet, and there's also a project that you guys can give it a try. Go here. You can also download the trained model from this. There is a Kaggle notebook for that as well. I'll share all the important links that are given. So inside this gender classifier, I'm loading these images, and they are also from the data set that I think I have made. Okay, so here you can see if I go to data sets, this is a data set of gender classification. This is the data set I'm talking about. So this data set has again 2 lakh images. There has a folder of training, validation, and test. Inside training, I have two folders of male and female. So you can train a model that can classify between a male and a female. So you can make a model that can classify it. Go to codes. There will be some codes available as well. And this is the popular code that I have made. So you can go here. So this is a gender classifier code that will help you classify if this is a real, this is a male or a female. And here I perform transfer learning on MobileNet. So here, as you can see, MobileNet is loaded. I'm performing training the model. And even after first epoch, the model has 92% accuracy. Okay, 90% accuracy on validation data. And after like 10 epochs, the model has 96% accuracy. 96% accuracy is huge number, right? And then eventually I'm saving this model. And if I'm giving this particular image, it is predicting it's a male. Okay. And here are some samples if it is predicting correctly or not. So what I'll do, I will save this model somewhere. And here you can see I've saved this model as well. And after saving this model, the model is given here. You can go to download model link. This is also the link that I'll share it with you. So you can download this model directly. Like this is the model card page, and this is the model gender classifier with MobileNet and gender classifier. This is the MobileNet version of it, and here you can see it is just 5 MB, very lightweight. And this is the model that I have trained from scratch. This also has like some decent accuracy, but not great as this one. So you can download this model, give it an image, and it will classify. Okay, so this part is also done here. And this also you can make very easily. This is just transfer learning applied on a specific data set. Okay. Now the final thing is finding the average male and average female noise. This is a tedious task. Okay. And for that, and this is the main task. If you understood this, rest of the things are pretty easy now. And for that purpose, here you can see this is a classifier style transfer notebook. Okay, this is the one I think. Model training, generator model. It's not having that file. Okay. Okay, this is not that one. No, that's this one. Okay, I need to find the file. Just give me a minute. But I hope it is clear so far. Do we have any doubt in this? It's like overfitting the validation accuracy is 54%. Yes, it might be, but for transfer learning on MobileNet, it was giving some decent accuracy, and we have given it a try as well. How generator is getting better? Is there other feedback? Yes, because if you go to the code, we are training both the models side by side. Do we have to train it for 6+ hours as well? No, this is not the assignment. Okay, this is the model that you can go try it by yourself, but this is not the assignment. Assignment is something that I'll give it to you at the end. Okay, so now I need to go to the generator from the content drive. Just give me a second. It was on GitHub only. I think I missed a link somewhere, but I'll share it with you. General file transfer. This is the one. Inside that, these are the important links. This is the Kaggle classifier, style transfer. Let me open all of them. One of them would be this one. If you look closely, basically, if I go to images.data.csv, inside this data set, this is a 2 MB data. Even if I download it and show you to you, this one will have the noise of all the images that are generating a female. Okay. And even if I show it to you, go to folder. So this is a 2 MB file. And here you can see this is the generated image of a female, and this is the noise that is given to the model. This is another noise that is given to the model. Here comes the third noise that is given to the model, and I have 1000 of them. So I have basically trained 1000 images. I have generated 1000 images from random noise and taking care of their noise as well, so that I can find the average noise of a male or a female. The exact same thing I have also done for male, so that I can also get a male image dataset where I'll have male noise. And in the exact same way, I'm getting the gender vector as well, where I have gone to the first CSV file, find the average, second CSV file, find the average, and eventually getting the final file as well. This is an NPY file, cannot be seen directly here, but this is a very simple file where I just have 100 numbers, 100 size vector. Okay, that will basically do the difference. This, I am finding the average male noise, average female noise, subtract both of them, I am having the gender vector. And now what I need to do, I will take a random noise. Where exactly I've written it? I have written it here. It's not there where I've written it. Okay, now what I'll do, I'll take a random noise, add this gender vector into it. Now I know the image will look more manly. If I'm adding it twice, it will become more manly. If I'm subtracting it, it will become female, more on the female side. Right now, I don't know, like if adding them will make manly or subtracting them will make manly. That doesn't make any difference. I'll do it manually. Okay, but I have got the gender vector, the average gender vector here. And once I have it, eventually your main task is to generate it. Okay, and now this is the model that is generating an image, and this one is not it. And in the meantime, if you guys have any doubt, let me know in the chats. Yes, this one has it, I think. Generating the images, high quality images. Yes, this one I have it. Great, I found it. And there's the model. I'll share all the links, important reference links with you at the end. Classifier, this is the classifier that is being trained. And there's the face generator with the CAN that is generating the faces. So this is the trainer part. And here comes the final part. Okay, great. I got the final notebook. Let me take some questions if you guys have it. Okay, what is gender vector? Okay, what is gender vector? Gender vector is just a vector that has the features of what is making a male a female or a female a male. So by adding it to any random noise, the noise will make it more to the female side or to the male side. Okay, is the noise like a random numbers? Yes, it's a giant array of random numbers. How many of them? 100. It's a fixed size 100 size vector. All of them, the noise will be random. How much parameter long is GAN? Okay, So for this part, you can go for generator and print the summary of it. You will get total number of parameters that we have in that network. Okay, so most of the things, but the restart, how do you get noise for male images and female images? Is it already in the data set? Okay, okay, I'll summarize that part as well. But eventually, what we are doing, we are not having random noises in between. We'll have random noise that will generate the images. Okay, this one will make the things clear. Now, what I have done, look here, I'm loading this model that can generate new images. So here you can see, given the noise, it's generating this image. I don't know how this is looking. This looking like half male, half female kind of an image, but eventually this is what we hit. But the thing is, now I'm doing a bulk generation. I'm going for a for loop that will do a bulk generation in 2 by 5. These are the images that we are doing. Okay, this is a better way of presenting it. That's it. Now what I'm doing, I'm loading this model. What is this model? This is the model that I have trained to classify the image generated is a male or a female. Remember, I'll make a classifier that will predict if the generated image is a male or a female. So here I'm doing that. So I'm loading this model, and here you can see this is the random noise, 1 by 100 size. Given to the generator, I'll get a generated image. And after that, this is how the image looks. And what my model is predicting, like there are 82% chance it is a male. Okay. And right now I'm just doing a prediction, like if, because this is a binary classification problem, last neuron is just giving you one value. So it's a zero. If it is zero, it's a male, one, it's a female. So I'm just adding a very basic threshold. So in this case, it is predicting this is a male, but this is not something that I wanted. So I need to go for a better thresholding. Rather than going for 0.5, now I'm going for, if more than 0.95, it's a male. If less than 0.05, it's a female. In between, the model is not sure. So I'm printing, I don't know. And I'm also doing a bulk generation. So this will generate these many images, like 10 by 50 of them. And for all the 50 images, it is going to predict if the model is very sure it's a male, only then print it. If the model is very sure this is a female, then only print it. Otherwise, print ID K. Okay, and here we are doing the same thing. But now as well, it's better than earlier, but not the best. But the model has learned something. Okay, so you can see this look like a male, this looks like a female, probably of long hair, again long hair, and this one is clearly a male, this one is a female. So the model has learned it. And now you can also go for, if our model is very sure that it's a male, only then print male. Otherwise, if your model is very sure it's a female, only then print it. So here you can see, now I have given it, if my model is, the probability of the model is 0.99, then only print the image. So right now what it is doing, I'm giving the generator some random noise. Okay, and once giving the generator some random noise, it can either generate the image of a male or a female, right? But what I am doing, I will not plot the image until and unless I have a perfect male image. Okay, with the threshold more than 99. So to generate 10 images, there are high chances that I might have generated 100 images. Out of those 100 images, just 10 of them fulfill that condition. So I'm plotting those images. Okay, so now these are the images that it was plotting. And here you can see, now inside this course, what I am doing, I'm generating 1000 images of male. Okay, and here if you look closely, I'm generating a CSV file inside that as well. So this is the same CSV file that I've shown you. This CSV file, what this will do, this will generate 1000 images that my model is predicting it is for sure a male. And I'm saving the CSV file. So the CSV file will have the images of a male, very confident male, right? And this particular model, this particular code will generate the images of female, 1000 images of female. Now I have a very basic question. why it took 45 minutes for the model to generate the images of male, and why it just took 13 minutes to generate the images of female. Why there is a huge difference? Gender vector is not something that I have added so far. I'm just generating the images from random noise, taking track of all the noise and what it is generating. And if it is generating a male image, I'm saving the noise. If it is generating a female image, I'm saving the noise. Training data distribution, Harinder is saying. Training data by Satnav is saying that is correct. Sonali, that is correct. Data is biased. Now, biased towards male or female? Data is biased towards male or female? Okay, now we have some mixed answers. They are more towards female side, but if you look closely, to generate images of female, I have 1000 of them. For generating 1000 images of female, I have 13 minutes. On the other side, here I have 45 minutes. So the model is biased towards male or female. So basically what this basically means, for the model, it's easier to generate images of a female than male. This is what it is showing, right? Because it took the model more difficulty to generate male images, but it can easily generate female images. So because of that, the model is biased toward female images. Right? So basically, when I'm saying 1000 images, this model might have generated 10,000 images. But out of them, just 1000 of them are male. But to generate a female images, I know the model might have generated just 2000, and out of those 2000, I have got the point. I've got the male images. Okay. So now I have two CSV files. One has the average, one has the noise of female images, another one has the noise of male images. And now if you look closely, what I am doing, very simple code. I'm loading male images, noise vector column, female images, noise vector column. I'm finding the average male vector, average female vector, and printing those vectors. So this is the average male vector. This is average female vector. Both of them will have the size by 1 by 100, right? And now I am generating these vectors as well. I'm giving those vectors because they are also male and female vectors. Now tell me, just a random guess, if I'm giving these vectors to a model, if I'm giving these vectors to my generator, I'm giving the generator, and here you can see I have defined a function. I'm generating a male image and a female image and plotting them. How the image will look? What is the image? How does the image looks? Good. Okay. Nilesh is saying good. The image will look good. Okay. So if I'm talking about the model, so can I see? Okay. So can you say like the image that is generated by the average vector of male will look manly and a female will look more female side, or it will look blur? Tanmay is saying blur. Why? The answer is correct. Those who have guessed it, blur, the answer is correct. It seemed like if I'm taking 1000 images of male and find the average image, it will not look like one single face. It's a mixed up of all the things, right? So that is why this is how the male vector look. This is how female vector looks. Okay. So right now they does not make any sense. It's written like this is male, female, both of them, but one of them is male, another one is female. Okay. So this is not good for anything. Okay. And it is mentioned like it will look good. It's not looking. Okay. This is good, anyone says, right? But now what I'm doing, I'm taking the average vector of male and average vector of female, subtracting them, I'll have a gender vector. That does make sense. Very simple, right? Now what I need to do, I need to now have average male vector, average female vector. Now I also have a gender vector. So what I can do now, I will generate a random noise. Okay. Now you guys tell me what will happen. I have a random noise and I have a gender vector as well. If I am adding random noise to the gender vector, random noise is again a noise of 100 size. Gender vector is again a noise of 100 size. If I'm adding both of them and giving to the generator, what will happen? Why both are females? Okay, it's just written. It's my problem that I have mentioned label female in both of them, but it's not like that. Okay, it's just a random human being, but it will be more on the male side or female side. If I'm taking a random image, but rather than directly given to a generator, I'm adding a generator, a gender vector, and after that give it to generator. Will it make a more female side image or male side image? Whatever it is doing, it would be more towards one gender, right? And if it is, for example, if I'm adding it is getting more toward male side. If I'm subtracting it, it will be more towards female side, right? And if I'm doing the double of it, adding gender vector and adding gender vector, so it will be more towards male side, more and more towards male side. If I'm subtracting it is more and more towards female side, or vice versa. I need to see if adding or subtracting will make male or female or not. Okay, now I'm doing exactly the same thing. Here you can see I have a noise, and here I have add a magnification. Like right now, I'll take the random the gender vector, multiply it with, add it with 0. That means there is no gender vector added. Now I'll add 0.5x of gender vector and minus 0.5x of gender vector. So it's basically I will generate an image. I'll add gender vector into multiple weights and subtract gender vector into multiple weights. So I'll have different variation of the same noise, but by adding and subtracting the gender noise into it. And here you can see this is a plot that I'm making. So this is how the model looks. This is what the model is generating. Okay. And can you say my agenda is fulfilled? Can you say my agenda is fulfilled? Like these images that you can see. Now they are not perfect. I'm pretty sure they are not perfect, as you can see as well. But all of them will look like one single face, right? They look like the same person adding gender vector into it. It's going more towards the female side. And if I'm going toward the left, it is looking more like the male side. All you need to do is go for more data, go for more quality image. It will, it will go for bye man. Yes, it will go more towards, it will become better. That's it. Okay. Now what I'll do, whatever I have done, I'll do it for multiple samples, different variation of the same image. Earlier I was going for 2, 4, 2, 4, 8, 9 samples. Now I'm going for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is how it looks. Okay. This one is looking pathetic. This one is looking a lot better. This one is even better. And what I can do, I can also go for in between variation like 2.5, 2.4, 2.3, 2.1. So the transition would be a lot smoother. Okay. And all of the things are being done through this gender vector that I have found. That's it. And here you can see I'm taking all the noises one by one, adding, multiplying it by the gender vector. I'm adding it for them. And here, because the number is subtracted, so obviously it will be subtracted. And this is how it looks. And if you look closely, can you find any pattern in this? Obviously, at the left, we have male, at the right, we have female. But can you find any pattern? Any major pattern in this? That is correct, Anand. Shiva, enough. Female images are comparatively a lot better. Male generated ugly in the set. Yes. Okay. So female look decent than male. Why so? Females are better. because the model is biased. Not just biased because this is what it is, but it's also about whenever I'm talking about data, this data set has more images of female. So first of all, the model is trained to generate the images of a female, and because of that, and it's not one or two for all the images. If I'm talking about the extreme end of keep on subtracting, and here you can see this variation is minus 2.5. So this gender vector, if I'm subtracting, it will generate the same image more and more female side. Adding it will generate more and more male side. So if I want to generate a realistic image of a female, I will take the random noise, take the gender noise, multiply it by 0.25, and then subtract it. So it will generate images that look something like this. Okay. And at the rightmost one are the most sensible, most decent images out there. Okay. And here you can see at the right as well. And now what I can do, I can also go for even more bulk generation for more smoother transition in between where I went for from -3 to 3, I'll generate 30 different steps. So here you can see this is how the transition looks. Okay. And right now at the left we have female, at the right we have male, but here as well the things is pretty simple. At the right we barely have a male, like at the right most we barely have a male that uh, is looking presentable. Okay. So but this model is a lot better at making female images. That does make sense. And what I can do, I this code will also generate a GIF, a GIF. Okay. And this one is saving the GIF as well. And how the GIF look, how that GIF looks, that's also pretty fun to see. That will basically summarize the whole project in one notebook. So if I go to repositories and gender style transfer, and here you can see we have a GIF file as well. So this GIF file is also generated from the code. So for every image generating from female to male, it would be better if I'm going male to female because that will look a lot better than this one. This one is like from decent images to pathetic images, but it should be on the opposite end. So the end should be good at least. So this is the whole project flow. Okay, jump scare. Yes, it looks like the same. Okay, now let me summarize the whole project. Okay, I know we have not done any code by writing it because it's not possible in a 2-hour lecture that I can make this project. It took me like a couple of days to work on this whole thing to make the whole project work. And that you can see that as well, right? Even after doing a lot of distillation in 1.5 hour, I'm able to explain you the project. Okay, and how I get the inspiration from that project, I would like to also add point in there. I was reading a research paper on how a neural network, so I just forgot the name of the paper. It's on how neural network dreams, and inside that is mentioned like how the style transfer can be easily done. And then I was working on already this data set, so I thought of why like then I was working on GAN based project. Then I thought, if I have a GAN that can generate images, can I guide this noise somehow that it will generate male or female based oriented images? And then I thought, this noise I can guide. Then I thought, let's have, can I find the average noise? As you can see in the presentation, right? In the presentation, we have seen I can find an average noise. And in the exact same way, if I can somehow find the average noise, it would be better. And to find average noise, first of all, I need to get only the man and woman images. And if I have this male and a female images, it would be better. Okay. So in that particular case, I went for doing this map by myself. And because of that, here you might have seen as well, this one has 3 separate repositories. Okay, I'm trying to embed all the things into one single repository as well. But if you go to repositories, Okay, I'm sharing all these links on the notebook, along with that all the important files in the resource as well. But on the resource, I cannot upload multiple files. So my expectation from you guys is take the reference from these links as well. How to reach there? Let me give you a brief again. You guys can go to uh, Ashish Jangda again. Then you need to go to GitHub. Okay, go to repositories, and then there are three repositories that are there. First one is phase generator. Inside the phase generator, we have all the codes to make a GAN based network that can generate new faces. This is the first step. Once we have it, the second step is to make a gender classifier that can classify this as a male or a female. And in the gender style transfer, this is the third project. You might be thinking this is the final project, but to make this project, I need to do a lot of other things as well. First of all, I need to have a generator. And after that, also need to have a classifier that can classify this is a male, this is a female. Okay, and then I need to go for average, finding the noise, doing the average noise. And this is, again, this is not the best way of doing this project. This is the thing that I've tried by myself. I thought if it is working, so I thought of adding it here, that like this is also an approach. uh you can give it a try and see if there is already paper there. That's great. If not there, it's open for you. Clear? So these are the three resources. I'm sharing all these three links here as well. Not only that, here you can see you can also download the model directly from this link. All the important links are also there in all the three models. And these are the trained models as well. You can also clone the repository. And this is also the one where you are doing this gender style transfer and things like that. Okay. And this time your assignment would be pretty easy. You are not going to have a very difficult assignment. Okay, it will be a very easy assignment. Okay, that I'll tell you in just a minute. But now I'm open to take some of your question if you have any. Okay, if you have any question, do write in the chats. I'll be taking like uh 4 to 5 minutes on this. And these are the links I'm also sharing in a minute. And this is the collab link as well, which is also doing the same thing. And this is the code that will load the GAEF file and show it to you, I think. Okay, this is not for the GF file, but this is also doing the same thing that we have done there. Okay, generating a different variation of the same image from left to right and doing a bulk generation and see how the style transfer works. What we need to submit, okay, just give me 2 minutes. I'll tell you about that. Now let me take 2 minutes to take the question. Okay. Uh, a lot of research has to be done on this one. Yes, you need to do a lot of research on this one. What to submit? I'll take a minute and tell you. How noise is added to data. So it is just a random noise that is given to the generator, and the generator will generate some image. And after the model is trained, there are some certain type of noise uh, that will generate the image of a male. Certain type of noise the generator will generate the image of female. In the beginning will not understand because they are random images, random noise coming in. But after analyzing the noise, like this kind of noise generating the image of a male, this kind of noise generating the image of a female, and how we got to know? Just map every noise if it is generating a very clear male or not, if it is generating a very clear female or not, then taking the average noise. That's correct, Shiva. And then the rest is the whole discussion that we have done. Okay. GAN ends at step 2. Yes, GAN is used just to build the generator. That's it. After that, the things stop there. There are different, a lot easier ways as well to do the style transfer. But I think your agenda should be uh, not making the project in the least amount of code you can do. It's like thinking and doing the things in the best way possible, or in the first principle, if I'm right. Okay, so Okay, what is the industry application of this particular concept? Okay, right now this is the fun project that I have done. Okay, very frankly speaking, but you can do, again, as I've mentioned, you can do the style transfer. For example, FaceApp is one of the example. Why FaceApp was very popular? There were some other algorithm models as well out there, but they are using a generative. I'm not pretty sure they are using GAN or not, but they are using some kind of AI to generate the whole new image. It is not an image processing kind of a thing where I'm taking the original image, adding an image, that adding glasses on your eyes that are clearly visible, that they are manually adding. They are using AI techniques. Okay, so to do those kind of things, and this model directly will not work. You need to do it on a scale. Give more data, use some better models, you add some more layers, and add some better classifiers so that it will do the style transfer in the exact same way I have done male to female transfer. You can also go for a sketch to image kind of a thing, where you will have a sketch in the beginning and you will generate a real life image of that. Okay, that's also something that can be done. Okay, and we are also going to have one more project on computer vision, and that is on unit, where we'll discuss about how we can take a lower quality image, convert into high quality image. Okay, we will take a black and white image, convert into a colored image. So there are different applications, not very widely used, but there are some specific kind of project you can make on this. Okay, use collab GPUs. Yes, we need to use collab GPUs. Otherwise, this model will take a couple of days to train. Okay, and then let's see how will it perform. Yes, we need to train for a couple of more epochs. What you can do, take the 700th epoch model, train it further. Okay, so you don't need to train from zero step and train for 700 epoch. Okay, why can't we predict the model bias initially? We can, okay, ideally what we can do in the beginning, we can see the data set. Okay, in the original data set, that link I'm going to share with you for image classifier, we might have seen this model has more images of a male, more images of a female than male. So we can balance the data set. So rather than taking all the images of female, I'll take, like, for example, if I have 10,000 images of male, 50,000 images of female. So I'll take 10,000 images of male, 10,000 images of female. It will make the data biased. Okay. But in the beginning, we have not seen it. And I want you guys to see the model biasness as well. Predict that this model is biased. Why it's biased? Because of data. Okay. It's gonna blur, right? Without the gender vector adding or subtracting, it will generate the middle image that was there in the whole map of either four images at the left, four images at the right. So without gender vector, it would be a neutral image, probably on the male side or female side. But adding the gender vector or subtracting the gender vector will generate the image of a female or a male. Subtracting it was generating a female, because as we have seen as well. So we just started very random data and start bidding upon it. Yes, this was the main agenda as well. I don't want to take a model that is already trained. If I want to make this thing, first of all, I'll train the GAN by myself that can generate faces. Then I'll train a classifier by myself that can classify this a male or a female. Then I'll find the gender vector by myself as well. And then by adding and subtracting it, as also given to the same generator to generate different things. So this is an end-to-end project. And not only that, the funny part is not the funny part, it's a good part. You guys should also try it. Even on the data set on which we have trained the image classifier, that data set is also something I have uh, pre-processed. It's not like it's my data set, it's original select phase data set only, but I have pre-processed it in such a way that this can be used as image classifier. Okay, so this is the data that is available on my repository. So you guys can directly go to codes and create a new notebook here. And you can also make the classifier then and there only. And here you can also see a lot of people already publish their work. There will be some work a lot better than mine as well. So make sure to check that out. So this is a gender classifier with 96% accuracy with these many upvotes. So I think I should also add that because my upvotes would also be like more than 190 because my model is also getting 96% accuracy. So it's more like how you name it as well. That's also very important. So that is the main agenda. And yes, okay, it'll be based on these concepts. AI is also based on these concepts. Yes, AI is an ocean. For a lot of you, those might know AI as well, might not have seen this particular side of AI, because this is also something that we are. Any system requirement on a laptop, nothing. All of the things that are going to run are on Colab or Kaggle Notebook. So all the resources will be available on the internet. So it's their resources that will require, not your. In yours, it will just a laptop, a charger, and internet connectivity. That's it. Which can be balanced or not female biased. DSP can use any dataset. You can also use a cat versus dog classifier and try to do the same thing. That's not the assignment for this, but you can give it a try, where you will take the data set of cat versus dog classifier. First of all, build a generator that can generate the image of cat and a dog, and go for the same approach. Then go for a classifier, then ask it to generate a cat, and then find the, again, not the gen we should not call it a gender vector. It's more on uh, cat to dog vector or dog to cat vector. Then adding it will generate the image of a cat and making transition to a dog. You can go for these kind of things as well. Learning techniques to get more data and males and females and then do it. Yes, you can also use data augmentation. Yes, Saish, that's correct. You can take the existing male images, the existing female images, perform data augmentation on that. So rather than having 2 lakh images, you can have 2 million images. 200,000 images are already there. You can have 2 million images, then train your model. Then it will take, like right now it is taking 7 hours, then it will take 70 hours. Then that is a problematic part, but it's just about giving more data, giving more time, the model will learn, the model will converge. Okay. Okay, so now let's do one thing. Let me share the assignment for today. It's not a very difficult one. I don't want to make it difficult as well. The project is already have decent complexity. But before giving the assignment, I'd like to know from you, how was the flow of the lecture? I know the you are bombarded with the information like, sir, I know I have this one, I have that one, this is what this that. But eventually the main agenda of this lecture is, or this whole series is, to give you a practical implementation. So that, and this is why I was thinking that I will give you 10 to 15 minutes intro, then we'll jump on code and then we'll write some of the code as well. But I was not aware that it will take 1.5 hour just to give you an overview. Okay, because if the overview is done, rest of the things are pretty easy. There are codes already there, you just need to execute. That's the rest of the thing would be fine. But okay, that's really good. Okay. Yes, yes, Samad. I totally agree to this. This was the agenda of this as well. That's why we spend most of the time to this. Ram is saying the session was Kadak. Okay. Okay. This is nice. Okay. This is nice. Okay. Thank you so much for the decent, good compliments. Though they may not
Ashish,
like.
one quick question. Sorry,
Yes.
you didn't answer me. So thing is, instead of random noise which we initially create, right? Can we upload our own image and try to convert that into a male or a female based on adding weights?
Okay. So that is the problematic part in this. Because eventually what we are doing, let me go back to this, and this is also a very important question. Sorry if I missed this question. This is an important question and I was thinking someone should have asked it. If I want to give my own image, eventually how can I give my own image? I cannot give my own image to this dataset. Why? Because the image is randomly generated from noise. How can I have noise that will generate my image? That is a big problem in this. So it will generate a random image. On that, it is doing a style transfer. If I want to make my own image, so first of all, I need to have one more network that can convert your all the images into the noise. Okay, that is again uh, uh, a reverse of GAN network, where you will have the classifier. It will be like you will have a network that will take the all the images as an input and generate their vectors. So it's like 100 size array, which is the summary of the whole image. This is what you need to. So you need to add one more model here that will be like an image compressor kind of a thing, where you will take your own image, you will generate a random noise out of it, and that random noise is the summary of your image. Then inside that noise, you can add the gender vector, and then it will do the things for you. Okay,
Uh,
have you got the point?
yeah, yeah.
You need to
Great.
add one more step, because
Got
right
it.
now, whatever the model will generate is pretty random. You don't know what the hell it is going to generate. So you need to add one more step into it. Okay.
And you did mention one more step, right? What kind of a model can I add to convert a actual image into a random noise?
Any CNN based model. Take the model, and here you can see, rather than converting into a dense layer, for example, convert it into a dense layer of 100 size.
Understood. Got it. Cool.
Okay.
Great.
Then take the output from that, and don't use softmax activation function because you don't want probability distribution. Just take ReLU activation function, and you also need to make sure if you should take ReLU or leaky ReLU or linear activation function, because what are the random noise we are giving to the model? If random noise are negative as well, we cannot use ReLU. We need to use linear whatever input coming in. We should.
There is some background noise. Okay. By the way, the session was really, really great. Thanks for the detailed explanation and also providing different ways of thinking also. Really good. Appreciate it.
Thank you so much. Means a lot to me. Now let's discuss the assignment for today. It's pretty easy, as I've mentioned. Your task is to take the train model. Okay, take the train model and generate an image out of it. Not just an image, but you need to do a bulk generation. Okay, because I know there are a lot of components into it. Your task is to take the train model. Which train model you need to take? You need to take this. Okay, you need to basically implement this project finally. The assignment that I'm expecting from you is you will be having a notebook. Inside that notebook, you need to have these these main components. You are going to load the pre-trained, and you don't need to train it. You need to load this pre-trained classifier, and classifier will not be needed in this particular case. Okay, eventually you need to generate the images. Okay, so you need to load the generator. Okay, and from the generator, along with that, you also need to load the average, the gender vector. Okay, generator has to be loaded, pre-trained. Gender vector has to be loaded. You can either generate it by yourself, but gender vector is also available in the existing notebooks. So you need to load that, and your task is to generate 10 different variations, like variations of the same. You need to generate 10 different variations of the same image, where at the left, and rather than 10, you can have 20 as well. That's totally up to you. The image that I've just shown you. So that will make the transition from left to the right, where at the left we can have male, or at the right we can have male, or vice versa. The project is pretty simple. Even if I can combine the existing code that are there, then also it will work. And I don't have an issue in that, because this is a complex project. Even if you have understood everything, and frankly speaking, you can also get the code to do exactly the same. So you can also submit that. I don't have an issue in that. This is a complex project. I totally understand that. Even if I want to give you a difficult assignment, so that would be difficult for all of you. So it will make the thing messy for you to get those who are putting so much effort to getting the refunds as well. So it is a very easy assignment that I will give it, that I'm adding. You just need to load the pre-trained generator. There are some codes already available. I'll add that code as well. So basically what I'll do within 5 to 10 minutes, inside the reference links, I will add a notebook. Inside the notebook, all these instructions are mentioned and all these important links are mentioned. You can also get the links from my GitHub, but there are also chance that you can get from the reference. So just give me 5 minutes. I'll make a notebook where I'll add all the important links from where you can get the project, and along with that I also add the assignment. Your task is to load the generator, load the gender vector, generate 10 different images of this. That's it. Okay, 10 different variation of the same, where at the left you can have a pathetic male, at the right you can have a beautiful female. Okay, because this is what the model is. The model is biased, so I cannot go ahead with it. Okay, so Tanmay has one suggestion. Please go ahead. And rest of you, I'd like to take couple of more questions, 2, 3 more questions, and then we can wrap it up. Okay, so directly copy pasting will not work, I know, because you need to understand the code. Directly copy pasting will not work. There are some problems that you will face for sure. Okay, but obviously there are some difference in marks. Okay, because eventually we'll evaluate. If you are going for like 10 different variation, if you are going for 20 different variation, you will get more marks. If you are going for 10 different variation and you are generating 20 images of those variation, you will get more marks. And even if you are adding a GIF that I have added, or if I can add an image per GIF and do the reverse of it, you'll get more marks. But eventually, if you can do this thing, the bare minimum criteria, you will get qualified. On top of it, however better you are getting, you will get more marks. Okay, because eventually what will happen, for us to standardize everything is difficult. There is a person who have done everything without documentation. There's another person who have done something with perfect documentation. If me evaluating it, and if Harshvardhan sir evaluating it, Sampur sir evaluating it, it would be different marks you will have. Okay, so for this specific project, and there will be one more project where the submission would be easier, but for rest of the project, it would be a difficult submission that you need to face. But okay, that's what it is. Because if I'm adding a different submission, a difficult submission where probably you need to do cat to dog or dog to cat, I know no one would be submitting it. Okay, or even if they can submit it, it will take at least 2 days. At least, even if they are copy pasting the whole code, it will take at least 2 days to do it. Okay, so fashion amnest one was easy too. Yes, that was also easy. We are beginners. Yes, I totally understand, guys. There are a lot of beginners who don't have that much of knowledge into these fields, but don't think of it as like you can get 100% out of it. Okay, even if people who already know it might not understand 100% out of it, your main agenda should be get the crisp. For example, have you understood GAN? How many of you guys have understood what is GAN? What is Generative Adversarial Network? Okay, that's something that most of the people understand, right? And you also know it will take some kind of noise as an input that will generate an image. And if you want to do the practical implementation of it, go to the code, run it. Even if you are not able to complete the whole project to do style transfer, at least you know how GAN works, and you can generate any class kind of an image. You can generate the image of cat or dog, just run GAN on any data set of your choice. That's also a project on its own. Okay, so how much you are understanding, try to do the applications of that. There's no one who will understand 100% of it. Even I am doing whatever things I am saying, I'm also not aware about everything. Okay, and this will happen when we are going to have a class on transfer learning, like GPT. When we are going to train the GPT from scratch, you will understand that even if the people who have made GPT, who have made transformers, don't know how it works, they know this works. If we are giving more data into it, it will get better, and if we are providing more GPU resources, it will work. But it's not like they knows everything. There is a threshold point. After that, people will not understand. It's just like quantum physics. It works, but how exactly even if quantum like physicists and scientists don't know exactly why it works. Okay, so it will happen at some point of it, but there are things that you should know. It should not like I don't know it because no one know the existing, or those are deep questions, but let's leave it there. So I know the sessions are a bit difficult. I totally agree to that point, but whatever you are understanding, just go ahead for that. Okay, and frankly speaking, I'm making it easy for you to do the submission, but eventually your agenda should not be to get the refund. Okay, it is one of the agenda. It is a driving force that will make you submit the project, but don't rush up, because if you rush up, your main task is to get the assignment somehow and not understanding the concept. Your task need to be going for the concept. The project that we have made, and like we are teaching in 21 days, it took us like 3 months of preparation to make those projects, even for us who's working in the industry from 5 to 6 years. Okay, so and there are a lot of nuances that are there, and you might have seen in the GAN presentation as well that I have skipped a lot of in-depth part. Whatever is needed, I was teaching you that, because you are not supposed to know everything. To know everything, there's an ocean. Even if you're dedicating, like even if after 5 years I'm saying I'm not even aware of like I'm even if I'm saying I'm an expert on AI, no, I just know like barely 20 to 30% of it. This is how wide the ocean is. Okay, but don't need to overwhelm yourself. There are some main component that we need to have. We are also going to have a dedicated lecture on this presentation, which I have given to you. This is the main where 80% of the things of neural networks are. There's the computer vision map that we have discussed. Mainly, we have discussed about GAN, and these are the two components that we have also discussed. There will be a dedicated class we are going to give to this one, and there will be two classes I'll give to these ones. One is to the sequential networks, another one on how LLMs are trained. So this is a notebook that I'll use very frequently. I'll update it very frequently as well. And this is the whole flow. I'll make it a bit better. Okay. So within 10 minutes, I'll update the notebook on the reference, and those who have attended the lecture, they know what to do. And eventually have a notebook file, PY notebook, either on Colab or Kaggle. If it's on Kaggle, share Kaggle link. Make sure it is public. If it is on Colab, make sure to share the link. Make sure that is also public. And if it is on GitHub, share the GitHub link. Make sure it is public. Okay. So thank you so much everyone for joining in. These resources I'll add on the notebook that I'm going to share on the reference link. And apart from that, okay, let me share the reference link, important reference links there as well. So this is the link for gender style transfer. This is for face generation with GAN. And there is another notebook for gender style transfer is done. Face generator is done. And what was the third one? Third one was gender classifier, yes. And inside that you will get all the important links that I've shared it with you. So 1, 2, 3 links are shared. And yes, eventually, if you still have any doubt, not right now, probably in the future, you guys can connect with me on LinkedIn. And LinkedIn link is something I've already shared with you. If not now, probably in the future. And okay, thanks, Ritik. Okay, take care, everyone. Thank you so much for joining in. And I'll see you in tomorrow's lecture. Thank you so much, everyone. Have a nice day. Thank you, Shuiz. Thank you so much, everyone.